Today we'll be discussing measures of dispersion. So students, what do you understand by the term dispersion? Have you heard this term earlier? Have you heard this term earlier, dispersion? I think the
No, sir.
science students who has physics in uh, there you have heard the term dispersion, I think. Dispersion, deviation, these are the similar kind of terms that we use when light flow goes in a particular path. When it comes to goes to a different medium, then it deviates from the original path, and that is called deviation, dispersion, diffraction. There are several terms that we use in case. So measures dispersion actually means uh, deviation or uh, movement from the actual path, or uh, diversion or difference. What is supposed to do, it is just gets deviated, it moves away. So that's actually the term dispersion means. So dispersion generally dispersion are there are several measures of dispersion, deviation. There are several measures. Generally, we have already discussed certain measures. We have talked about the range. So please keep your pen and pencil ready, pen, paper. So range or span, we have already discussed that. What is range or span? Remember when we have started discussing with the data set that I have given the maximum value, I found out the maximum value and the minimum value, and the difference between the maximum value and the minimum value is called the range. So range or span defines the whole data belongs to that particular range or particular uh, so not all the values are same. Whenever we are talking about real life quantities, say if we are talking about the marks obtained by the 50 students, so not everybody gets the same marks. Or if I talk about the height of the students, or height of or Virat Kohli's score in cricket in test matches. So he does not score same runs every day, every innings. So there is a deviation. Sometimes he scores 0, sometimes he scores 200, sometimes he scores 150, sometimes he scores 33, sometimes he scores. So similarly, in a class, if we try to measure the height of the students, somebody is 5 feet 6, somebody is 6 feet 1, somebody is 5 feet 1 inches, somebody is less than 5 feet. So, and we have talked about the most of the students are uh, in between. There are some deviations, like few of them are very small and few of them are very tall. So that's why the deviation is, there are deviations from the mean here and there. So whenever we are talking about the deviation difference, so not everybody is clustered in the same way. There are there are some values which are lying above the average. There are some values which are lying below the average, and that's why there is a span, there is a range, there is a. So these are the different terms that we use to measure dispersion. So one of them is called range. The other one can be talked about. We can talk about deviation from a particular value xi, or sorry, I'll not say xi, deviation from a particular value, a constant term a. Say if I am saying, say there are, say I am say I have 10 values, 10 values means marks of 10 students, say like 56, 41, 25, 35, 40, 27, 33, 42, 63, 1, 2, 3, 4, 5, 6, 7, 8, 9, and say 37. So if I ask you what is the deviation of this mark, see these are all the values are not same, they are different. So there is a variation, there is a change. 56, 41, 25. So some values are, so if you try to find out the average, can you find out the average quickly? So please find out the average marks quickly of this data. So the average we can find out by adding all the numbers, and average is 39.9. And we can see that there are some values which are more than the average and some values which are less than the average. So let's take, if I ask you what is the deviation of each value from a constant a, and that I'm saying that is equals to 40. So what is the deviation from 40? So that means deviation from a constant value a is 56 is greater than 40. So the deviation from 40 to 56 is 16. That is 56 minus 40. Then next one is 41 minus 40, that is plus 1. Plus 16 plus 1, then this one will be minus 15, isn't it? So if I divide, so deviation from a value is given by xi minus a, where a is a constant and xi are the values that are given. So can you find out the deviations of each value? And we will define mean deviation from a is equals to summation modulus of xi minus a by n. So that means what we will find out, we take the deviation from a, and as there are some positive values and some negative values, because some values are more than 40, in this case a is 40, so some values are more than 40, some values are less than 40. So there will be some positive values, some negative values, and if we add all of them, if we take the summation, then the value becomes diminished, that the total value becomes lesser, and it may happen that the summation of xi minus a, summation of xi minus a may become 0 in that case if we do not take the modulus value, and that will imply that there is no deviation. But that is not the case. We can see the original values, we can see the values are different from 40. So there are some positive values, some values which are more than 40, there are some values which are less than 40. So that is why, to remove that ambiguity, we take the modulus value. So I understand that you can find the value modulus as so modulus means the positive, only the positive deviation, positive value, or you can define this way also, summation of we can write this way, equals to summation of xi difference a by n. So can you quickly find out what is that value? What is mean deviation from a for this particular set of data? Have you can you quickly do that and tell me what is the value? Just take. So we have already calculated the minus values, isn't it? So these are the xi minus a, are the values are 16, 1, minus 15, minus 5, 0, minus 13, minus 7, plus 2, plus 23, minus 3. Everybody agrees to that?
Yes, sir.
And if we take the
Yes, sir.
modulus, then these values, negative values will become plus. So plus 15, plus 5, plus 13, plus 7, and plus 3. So if you take the sum, what is the sum?
85.
85, sir.
85. And hence mean deviation from 40, here a is 40, is 85 by 10. So that means 8.5.
5.
So that is the definition of mean deviation. So what does it mean? That it means at an average the values deviate from 40, each value deviates from 40 by the range 8.5. And most of the values are lying between 40 plus 8.5 and 40 minus 8.5. You can check, see how many values will be lying between 40 plus 8.5 and 40 minus 8.5. See this value, this value, this, how many? So 6 of them. isn't it? Plus and minus, if I'm considering plus 8.5 and minus 8.5. So 6 values lying in between, and the 4 values are a little bit apart. So that's what the central tendency you have talked about, and the deviation, a measure of deviation is all about. Okay, and similarly we can define mean deviation from mean, that is MD x bar. So how we can define that? Mean deviation from mean is equal to summation modulus xi minus x bar by n. So this is how we define mean deviation from mean. I think we have already defined, denoted mean as x bar. So in this case it's a particular value, that
Sir,
is
the
x
board
bar.
is stuck.
That is x bar. Instead of a is a constant value. Instead of a, we will be taking for mean deviation from mean, that is defined as x bar is the mean. So we have already found out mean as 39.9, isn't it? Sorry, 39.9, isn't that what we have found out?
Yes,
Yes,
sir.
sir.
So can you calculate this mean deviation from mean? So can you calculate for the same data quickly? Can you calculate for the same data? The third measure of dispersion can be defined as mean deviation from mean. Here this mean means x bar. So that's how what we have defined as MD. So mean deviation is MD x bar. How we have defined that? That is equal to summation modulus of xi minus x bar by n. Previously, we have defined mean deviation from a, where a is a constant, any particular value. But here x bar is a specific value. Specific value because it is related to the data set. It is related to the data set. How it deviates from the data set. And instead of a, we will be using the mean of the data, and we have to find the mean of the data and then find the mean deviation from mean. So please quickly, is it okay, Suparna? Have you followed?
Yes, sir.
So
Yes.
please calculate same
Now we will
data
take exact
or
39.9 over
9.
here,
Yes, we'll
right?
be taking exact 39.9 and calculate. Yes, I think it will be similar kind of values. It will be, I think, similar values. So can somebody tell me what is the sum of modulus xi minus x bar? I think it will be around that 85 or what you have got previously. It will be similar to that. How much you have got? It will be an exact value in that case. Hello, how much everybody is doing it?
Sir, we are doing.
Yes, yes. Just so what we get is, if mean deviation from mean, also we get summation is equals to 85, and again we get 85 by 10. So that means this will be 8.5. So similar values we are getting. Then there could be some other deviation called quartile deviation. Sorry, quartile. TILE, quartile deviation. Now, yes, we haven't defined what is a quartile. Let's define what is quartile. Q1 is called the first quartile. Q2 is the second quartile, and Q3 is the third quartile. Actually, Q2 is nothing but the median. We have already found out what is median. First quartile, second quartile, and third quartile. Now, whenever we talk about say year, what is now we are in the fourth quartile, isn't it? So actually, quartile is nothing but dividing the data in four parts, four equal parts. So we have already said in case of median, we have already said that we have to arrange the data
Your
in the.
voice is breaking.
Hello, my voice is breaking.
Yes, sir.
Okay,
No, sir.
so I hope you understand, you can hear me properly now. So I think we have said while calculating the median, we have uh, arranged the data in the ascending order, and we have defined median as the middlemost value, if you remember. So here, that means this is the data set. I'm dividing the data set into two equal parts. So the middlemost value gives you the median, and if I divide the first half in equal two parts, that gives you first quartile Q1, and the second part, if I divide it equally, maybe the figure is a little difficult, we'll get the third quartile. So that means dividing the whole data set in four equal parts gives you the. So now we are in, today is 23rd December, that means we are in the fourth quartile of the year. And so quartile means 3 months. In case of a year, first 3 months is the first quartile. Next means January, February, March is first quartile. Second quartile is April, May, June, like that. Now in case of data, Q1, Q2, Q3 has the same sense. Q1 and Q3 has the same sense. The way we have found out median, Q1 and Q3 will be found out in the same manner. Only difference, in case of Q1, we will use the definition as L plus, here it will be, instead of n by 2, it will be n by 4, isn't it? Because in median definition there was n by 2. So why it was n by 2? We were trying to divide the data in two different halves. Now for first quartile, we are considering the first half part. So that means we are dividing the whole data set in four parts: 1, 2, 3, and 4. So first means it becomes n by 4 minus f minus 1 by f0 into h. Same definition. Mind that af minus 1 and the f minus 1 used are not same. Here f minus 1 means for finding the first quartile, the previous group. Do you understand? Do you follow what I'm trying to say?
No, sir.
Okay.
Sir, can you please tell again?
Yes. Okay. I'll give an example. In that case, you'll be understanding what I've tried to mean. Let me write the formula. Let me write the formula for all Q1. I have already written Q3. Please write Q3 is L plus 3n by 4 minus f minus. Okay, let me write it in a. So Q1 is L plus n by 4 minus f minus 1 by f0 into h. Q2 also we have written same thing, n by 2 minus f minus 1 f0 into h, and Q3 is equals to L plus 3n by 4 minus f minus 1 by f0 into h.
So quarter 2 should be 2n, right? 2n by 4.
2n by 4.
Or n.
Yes, 2n by 4 is same thing as n by 2.
Oh,
Right? What you have said
okay.
is right. What you have said is right. 2n by 4. Okay, let us write that 2n by 4. If you take the simplification, mind that what I'm trying to say is that this f minus 1, this f minus 1, and this f minus 1 are not same, but has the same sense. I'll explain. Similarly, this f0 and this f0 are not same value, but it has the similar sense. I'll just try to explain what I mean. Okay, give me a minute. Give me a minute. I'll try to explain with the set of data. Okay, please write down the formula, then I'll come back. Okay. So let's take this data where we are trying to find out the first quartile, second quartile, and third quartile. So the groups are from 5 to 15, 15 to 25, 25 to 35, and the frequencies are given as 2, 7, 10, 12, 9, and 4, and where n equals to 44. Now, as I've said, Q1 and Q3 has similar sense as that of median. So for median, what we did, if you remember, we have found out the We have found out the cumulative
Cumulative
frequency.
frequency.
Cumulative frequency less than type. So please find out the cumulative frequency less than type. So this gives you 2, then 9, then 19, then 31, 40, and 44. Isn't it?
44.
Cumulative
Yes, sir.
frequency.
Yes.
Yes.
So now n by 4. N by 4 equals to how much? N by 4 is 11.
Yes, sir.
N by 2 is 22 and 3n by 4 is 33, isn't it? Isn't it? N by 2 is 22
Yes, sir.
because
Yes.
Yes, sir.
and n by 4 is 11 and n 3n by 4 is 33. So that means, as we have said, how we have defined, if you remember, how we have defined median class. Median class is that class for which the cumulative frequency just exceeds n by 2, isn't it? So
Yes,
that's
sir.
how we have defined the median class. That means in this case, n by 2 is 22. So which group has the median? Which class has the median? Cumulative frequency just exceeds 22 is this 31.
35, 45.
Yes, this is 30. So this is your Q2 or median class. Do you get? Do you get it?
No, sir.
Who's this? You are not present in the last class in that case.
No, sir, I was. I couldn't get this one only.
Why not? Cumulative frequency just exceed. N by 2 is 22. So cumulative frequency more than 22. Which one? Which one?
Okay,
Tell
sir.
me.
19 previous one. Yes.
No, no, I'm
31.
not. I'm not saying previous. I'm saying exceeds more than 22.
Yes, sir.
Yes,
Yes,
that
sir.
is 31.
31.
So that is the median class. That's how we have defined. Median class is that class for which the cumulative frequency just greater than n by 2. Exceed means greater than. So this, is it okay? Hello.
Yes, sir. Yes,
This
sir.
is your Q2 class. Now, similarly, for Q1 class,
25 to 35.
oh, okay, right. For Q1 class, it will be just exceeds n by 4 because your Q1 class is related to the first quarter. So just exceeds Q by 4. That means just exceeds 11. Do you get my point? Hello. So
Yes, sir.
as
Yes,
Yes,
sir.
somebody
sir.
has said, it is, so this is your Q1
Yes, sir.
class. Eh?
Yes, sir.
And Q3 class will be the third one.
45 to 50.
Isn't
40.
it?
Sir,
Yes,
45
sir.
to 45.
This
55.
is your Q3 class. Okay? Okay?
Yes, sir.
So, so when you are trying to find out Q1, please listen carefully. When you try to find out Q1, I will ask somebody please answer. So what will be the value of L, capital L?
25.
Sir,
25.
25.
25.
Yes, lower
5.
class boundary of that corresponding class. So 25 will be capital L. What will be the value of capital F minus 1?
So 9.
9.
9, right? Exactly. That's what I was trying to say.
9.
It is similar sense. Previous class. Do you get, everybody follows? Whether everybody is following what I'm trying to say. When you are
Yes,
trying
sir.
to find
Yes,
out
sir.
Q1, your L is 25, F0 is 10, capital F minus 1 is 9.
9.
When you are finding Q2, your L is
35.
35, your
55.
capital F minus 1 will be 19,
19.
and your
19.
F0 will
12.
be 12.
12.
When you are trying to find out Q3, your capital L will be 45,
45.
your F minus 1 will be 31,
31. 31.
and small m
Sorry.
is
9.
so please quickly calculate those three values. Acha, another thing I just like to say that it is quite possible that Q1, Q2, Q3 belong to the same group. It is quite possible. But the values could be calculated according to the formula. It depends upon the
Sir,
data. Is it
sir,
okay?
8 means n.
H means length of the class. 30, 10.
Okay.
H means 10.
10.
Length of
Okay,
the
sir.
each group. Length of each group. That is H. So please quickly, you people, students, please quickly calculate Q1, Q2, and Q3. Okay? Quickly. I give you 3 minutes. Places of decimal. If the values are coming in
Okay, sir.
decimal, please calculate correct up to 2 places of decimal. So we find out the values of Q1, Q2, Q3 as. So Q1 we get as 20. How much is Q1?
27.
27.
27.
27, sir.
Q2 is 37.5.
37.5.
7.5, sir.
Okay, 37.5. And Q3 is 47.22.
47.2.
So this is what we
Yes, sir.
get. So that's what I when I've tried to say Q1 and Q3 has the same sense, similar sense as that of Q2. I hope you understand what I mean by that. So now we can use this Q1 and Q3. So there are two measures of dispersion. Maybe there are two measures of dispersion. One is interquartile range, interquartile range, uh, and there is interquartile range or interquartile deviation that is defined as Q3 minus Q1 by 2. That is also a measure of dispersion. Q3 minus Q1 by 2 is measure of dispersion. Just so please calculate that. Quartile deviation is quartile deviation is same. How this is Q3 we have already calculated 47.22
2
and
2
Q1 is
minus.
47.
22.
27.
Oh, okay, sir.
27, sir.
20. Just put the values and get it done. So 27. So 20. Yes,
1, 1.
around 10 point
Yes, sir.
10.11.
1, 1. Yes,
10.11.
sir. Yes.
Okay. Also, there is another one, another measure. It's called coefficient of quartile deviation. Coefficient of quartile deviation, and that is defined as Q3 minus Q1 by Q3 plus Q1. So quickly calculate also. Quickly calculate. So these are different measures of dispersion. So quickly calculate for this same data set. The one we can find out. So quickly. This is 20.22 divided by I think 47
74.2.
74 point something.
74.22.
So it gets about how much?
0.2724.
0.27 like that. So 0.27. So that is coefficient of quartile deviation. So all these are different types of measures of dispersion. But the most important measure of dispersion that we haven't talked about yet, we are interested in this. This is the most important measure of dispersion. That is called standard deviation or root mean square deviation. So this is the most important measure of deviation, standard deviation or root mean square deviation. We denote this by sigma, and we defined the sigma is calculated by the formula. Please write. This is for individual value. So as the name suggests, root mean square. I'm writing this root mean square deviation. sorry, root mean square. Let me write again. Root mean squared deviation from mean. So how this is defined? This is defined as, so it will be calculated backwards. So first one is deviation from mean. So how we get deviation from mean? That is xi minus x bar. So deviation from mean, but as we have said that deviation, if I take xi minus x bar, that could be positive or negative. We have already calculated that. To make that positive, previously we have taken the modulus sign. Now here what we will do, we will square that. If we take the square, then also it will become positive, it will become plus. So deviation, first we calculate deviation from mean, then we square that, then we take the mean of this. So how to find the mean? We just add and divide by the number of data. So that is the process of mean. And since we have squared, to bring that in the same level, we have to root. So that is the formula for root mean square deviation from mean. Let me write it again. So sigma is the root mean square deviation from mean whole square by n. In fact, we will not be using this particular formula, but this formula can be simplified in a better manner. That will be much more easier to calculate, and we will use this particular formula as root over of summation xi square by n minus x bar whole square. So that will be the simplified formula for standard deviation or root mean square deviation. Mind that xi square means first you square, then you take sum. First you square, then you take sum, and then you take the division. X bar means mean. We will be doing the same calculation with the same data set, and this is for individual data. This is for individual data, not for group data. Now for group data, the same formula changes a little bit. For group data, the formula becomes, for group data means where we have frequency, the definition becomes summation fi into xi minus x bar whole square by summation fi. So that is the formula for standard deviation. And if you simplify this, this becomes summation fi, please write, I hope you are writing fi xi square, sorry, by n minus summation fi xi by n whole square. So this is the formula for group data. Mind that this is formula for group data, and the previous one is for ungrouped data. So let's do an example for both quickly as possible, and we will uh, uh, finish the class today by doing the example of this kind. Have you written? So it can be written as a so let's take an example first. Suppose we have 8 values. So xi, that means 11, 13, 19, 25, 27, 34, 40 and 46. So how to find the standard deviation of this data set? So why I am writing this xi? Mind that the first one, I think I have already said, the first one is x1, second one is x2, x3, like that. So we have 8 values, that means it's up to x8. So how to find out the standard deviation of these 8 values? So what we do, we will find out xi, and given xi is given, no frequency is given. Remember that there is no frequency. So what we'll do, we'll only calculate xi square. So quickly find out xi square. Just square each of them. So it is 121. Keep your calculator ready. 13 square is 169, 19 square, 25 square is 625, 27 square. Please quickly tell me values. 40 square is
Sir,
60.
27 squared 729.
Uh, uh, 27, 29.
27.
Then
Yes, sir. 34 square is
19 square is 381.
261, sir.
361, na?
Yes, sir.
361. 34 square is
34, 1258. 58.
1258. And 46 square is
Square is 2116.
2116. So we have found out xi square. Then we need, so to use the formula, sigma equals to root over summation xi square by n minus x bar square. So x bar square is means summation xi by n whole square.
Sir,
So
something is
Sir,
wrong here.
sir,
30
34 square 1156.
is 1156.
34 square is 1156.
Yes,
Yes,
sir.
sir.
Okay. One,
Yes, sir. Sorry, sir.
okay. Please correct. So,
Sir,
so
40,
And
46
sir,
is 2116.
46
46
square is
square is
2116.
2116.
Yes, I have written that. See, you do it correctly. My stylus is not very fine, so I'm writing. My writing is a little bold. So you do it yourself. So that means in this case we have to calculate summation xi also. So find out the sum of both the columns, summation xi as well as summation xi square. So tell me what is the value of summation xi
215.
and summation xi square, both the values. Tell me.
Sir, 6877. Summation xi square and summation xi equals to 215.
Summation xi is 215. Everybody agrees?
yes, sir.
And summation xi square is?
6877.
Can't hear you. Hello?
6877.
687.
6877.
77. Everybody agrees? What about others?
6877. Yes, sir.
Okay, so
Yes, sir.
6877. So now we have found out the values. So put the values in the formula. So let me write. Please. So here sigma equals to. So summation xi square how much is 6877 divided by what is n? N in this case is 8.
8.
There are 8 values. And summation xi is how much is summation xi?
215.
215. So 215 by 8 whole square. So quickly calculate and tell me what is the value of standard deviation sigma, how much you get. Quickly calculate and tell me. I am also trying to find out the value as quickly as possible. So calculate and tell me. So 6877 and
Sir, 28.85.
everybody agrees.
Sir, answer.
28.85.
No, 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 স্যার ওটা হোল স্কয়ার আছে।
Sir,
Quickly.
11.72.
Huh?
11.72.
11.72. What about others? What about others? What the others are saying? Quickly. Quickly. What about others?
Yes, sir, 11.72.
11.72. আমার তো বেশি
Yes,
মনে
yes,
হচ্ছে
sir.
মনে হচ্ছে
আচ্ছা আমি হোল স্কয়ারটা তখন কি দেখিনি ওই জন্য
11.72.
11.72
Everybody is getting 11.72. So that is, I accept 11.72. So 6877 by 8 means 6877 by 8 means how much you are getting?
859.62.
8
Yeah, 8 minus 215 by 8 is about 215.
26.875.
26.8, that square. If you take the square, so it will be. Uh, I, I, I I
72.2.
guess I guess everybody is getting to 11.72, so then it's okay, fine.
Yes, sir.
Yes, sir. Yes, sir.
11.72.
Okay, so no problem. So let's so that's how we do for an ungrouped data without frequency. We use this. Now let's do the last thing for group data. Let's see how to calculate the standard deviation. So this is the group data that we are discussing from the beginning. So we have 8 groups, 24 to 33, whose frequency is 7, 33 to 42 frequency is 7, and this is the data set. So for this, how to find out standard deviation? Now for standard deviation, we need to first find out, because we need to find out the mean also, so we have to find out the mid values. So mid value is your xi. So mid value is xi. So how much is the mid value? If you remember, we have just added this 2 and divide by 2. So 24 plus 33 divided by 2 gives
28.
you 28.5, isn't it?
Yes, sir.
Then it is 37.5.
37.
37. Just find out the mid values of each group. So those who are not there previously, they can also learn. We have done the same data, same problem. So just add those two boundaries and divide by 2. So 42 plus 51 divide by 2. So gives you
46.5.
46.5. Then it is uh, 55.5. Then it is 64.5. Then it is 73.5.
73.5.
Then it is 82.5, and finally it is 91.5. So these are my xi's. Now for what we need is xi square. So xi square, then fi xi and fi xi square. So these are the columns that we need. So xi square means just square these values, each of them. Then fi xi means fi is already multiply this with this, that will give you fi xi, and fi xi square means multiply fi with xi square, this value. So just calculate and finish the table. I'll give you 5 minutes time, to 5 to 6 7 minutes. So please calculate, then sum fi xi and sum fi xi square. Then I'll give
Sir,
you
FI means frequency to.
fi is a frequency column, is the fi.
Okay, sir.
Just multiply square, and then I'll give you 3 minutes. Then I'll just write down the values. I'll not do it. You are supposed to do it. You please do it. I'll give you 5 minutes to calculate these three columns quickly. We have got summation fi xi as 2847, and summation fi xi square equals to 180148.5. Now we put the values in the formula of standard deviation. So as I have said, the formula for standard deviation is summation fi xi square by n. So summation fi xi square is 180148.5 divided by n. How much is n? Is 50, isn't it? Summation fi is n is 50, and here it is summation fi xi is 2847 by 50 whole square. So just calculate and get the. In fact, we have already found out this x bar earlier. We have already found out this x bar earlier, isn't it? Previous, when we have done the mean. When we have done the mean, we have already found out that. So please calculate. So 2847 by 50 whole square. Mind that I have put a bracket and then I have put the square. So quickly calculate and tell me what is the value. I am also calculating. I am also calculating. we get 18.994. 18.994. So just as you can see, the calculation is quite a bit tight. I mean, it's very what should I say,
Lengthy.
lengthy. The data is, if there is a point, the decimal values, in that case, it will be quite I'll not say difficult. You may make mistakes while putting the values in the proper place, while putting it in the calculator. So it's quite possible that you can make a mistake while calculating. But the process is not that difficult. Just follow the process and you can find out the standard deviation this way. So next week, next day, we'll try to find out. Actually, we'll find out how to simplify the calculations. Anybody has any question, please ask. I hope everybody can do it. Everybody has done it properly.
Yes, sir.
Yes,
So,
sir.
Yes, sir.
Mr.
Yeah.
Muskan, all of you,
Yes, sir.
just put the values in the proper place. Formula is pretty simple. There is not much, but it's a tedious calculation. Is a little bit tedious, and I hope you can do it well. And next day we'll see how you can simplify the calculation. We'll try to practice some problems. I'll give some problems to exercise, and
Mm,
you
So have we
practice
covered
this.
the entire chapter?
More or less, more or less. See, these are the basic things that we require. Uh, I'll give you some problems to, because it's only said mean, median, mode, standard deviation. So many things are there in this module one, topic one, and there are several other things to be discussed. So I cannot give much time in this. So for basic practice, you can have some practice for your own good. We'll discuss different types of problems maybe later. Okay.